Hello, everybody. And this week, our topic is Heliophysics Decadal Surveys. So we can start first with just a little bit of the purpose of these surveys. They're conducted every 10 years. That's why they're called the decadal ones. And they determine the priority science goals of the community for the upcoming decade. And we do this so that we can have a comprehensive strategy in order to achieve those science goals. And then also to allocate the appropriate amounts of funding for each of the projects that we want to focus on. And then also the purpose is to assess the current expertise of the workforce and then address additional required capabilities. So if we are lacking in any aspects, we could get help there and support our goals. And so for the 2024 Decadal Survey, it's run by the National Academies of Sciences, Engineering, and Medicine. And the title for this specific survey is called The Next Decade of Discovery in Solar and Space Physics. And the subtitle is Exploring and Safeguarding Humanity's Home in Space. And so for today's meeting, we're joined by Dr. J. Todd Hoeksema, and I'll give his little intro. COFFIES PI J. Todd Hoeksema is a professor of physics at Stanford University. His primary professional interests are the physics of the sun and heliosphere, with particular emphasis on measurement and understanding of the solar magnetic field, and also enjoys strategic planning. He leads the Solar Observatories group at Stanford and has been involved with 3 solar observatories, the Wilcox Solar Observatory, Michelson Doppler Imager and on SOHO, and the Helioseismic and Magnetic Imager on SDO. He spent 4 years as a heliophysics discipline scientist at NASA HQ and has served as the chair of the Solar Physics Division of the AAS. He earned a PhD in applied physics at Stanford and was recently named a distinguished alumni of Calvin College. And his favorite coffee is Pete's Mocha Java, which I thought was a very fun fact. So thank you.
Sure, my pleasure. Nice to meet you all. I guess we'll dive in. Maybe I'll just say a couple words as we get started. Yeah, I've been involved with solar physics and heliophysics now for about 40 years. And so this is my 4th or 5th survey that I've had something to do with, or at least been interested in. And it's really an interesting process that the community goes through to pull these together. What I'm going to do today is walk through the slide deck that they provide for the researchers, and then give you a little bit of background on it, and then hopefully that'll lead to some discussion and questions. Phoebe gave you a really nice introduction there at the beginning about what we're doing and what the purpose of these things is. One of them is to assess the current state of the art. And in fact, if you're just getting started in heliophysics or solar astronomy, a great place to go is to decadal surveys from the last 1 or 2 of them, because they're written not for specialists. They're written for people who are intelligent, but not necessarily educated about solar physics and astronomy and heliophysics. And so it's a very nice summary. It's also, top level, but it goes into enough detail that you can kind of understand what it is and explains why you want to do the science that we want to do. So again, if any of you are interested in getting a good overview of what heliophysics is about, it's a great place to start. The other thing is that it's really good for the community as a whole. Everybody contributes a lot to these. We'll get to the numbers in a few minutes. I think there were like 500 essays that groups of people put in during the process. And it really taught everybody about what people thought were going to be the interesting things. Now, not all of them made it into the survey, and that part of the process that's also interesting. But what happens is, the people who are on these committees read every single one of those things a couple times, typically, and then try to come up with some sort of overarching themes and goals, and basically establish a set of priorities for the coming 10 years. And that's the other purpose, of course, is to take all the good ideas, of which there are hundreds, and boil it down into a few things that you think you might actually be able to get done. We don't always get all of them done, but it's a really good way to sort of focus in on what the big project should be. It doesn't go into a lot of the little projects. So like your research grant that you wrote or your professor wrote, wouldn't be something that would be necessarily guided by that directly. But indirectly, it really is guided by that because what happens is NASA takes the Decadal Survey and the National Science Foundation to a less extent, and NOAA to some degree, and they use that to develop their decadal plan, which they update every few years. They used to have roadmaps. It's been a while since we've had a NASA roadmap. But those rely heavily on the priorities that are set by the decadal surveys. So NASA really lays out its program and the way it's going to approach it based on the scientific priorities of the decadal survey. That isn't to say they always do it the same way that the survey tells them to do. So the survey comes up with a strategy like, okay, if you sent this mission to this place with these instruments and this mission to this place with those instruments, then you could accomplish the science. But NASA can do it in a different way. They can say, well, we don't want to do this instrument. We want to do this one that'll do part of this one and this one, and we'll do an explorer over here and something else. So that they have a lot of ability to decide how to implement the program. And the Decadal Survey is sort of an existence proof that you can actually do all this science within more or less reasonable budget, although they always are a little bit generous with themselves, and then figure out. And that leads me to the final purpose. The final purpose is really to set funding priorities for Congress. Congress asks for these surveys, and they use them to help them decide what they should support. The agencies are sort of bound to consider them, and then Congress has to actually provide the money, and the administration then has to implement it. And without knowing what's important and why you want to do it, they would have no guidance. They would just, somebody would go to a person in Congress and say, "Oh, this is my favorite mission, and I'm one of your constituents, and we do lots of good stuff. Let's do this." And every year you'd get a new set of priorities. So this is really a way to organize the whole community, but also provide insight into the people who are actually making decisions about how the money gets spent, to actually implement the program. So it's a really important thing, and it has a lot of influence. It first started with the astronomy committee back in, oh boy, the 1960s made the first decadal survey. And at that point, heliophysics wasn't a separate discipline. It was really part of that. And it wasn't until about three surveys ago that the heliophysics, the planetary science, and the earth sciences all came up with their own surveys. So before that, there weren't as many, but it was so effective for the astronomy community that the other ones that are sort of associated with NASA science started their own. And it has been really effective over the years. Some of the instruments take a long time, like the Parker Solar Probe was first proposed back in the 1960s. But the mission was too expensive and too hard. So even though it was a scientific proposal, it wasn't really something that they could do. It was more of a dream or an idea than a plan that you could actually do. But a lot of these ideas come up, and until recently, they've actually gotten a lot of it done within, if not within 10 years, within 15 years. Looking forward, it's not quite so clear. There's been a lot of discussion, I'm sure you've been watching it in the news too, about what's NASA going to do and how is science going to be implemented and what's the funding going to be like. And if they cut the funding by a significant amount, obviously you can't do the program that was based on a certain assumption. So I'm not going to get into that today, but I just want you to know that it may or may not happen. And you mentioned that you talked about the drive centers. One of the recommendations in the previous decadal survey was that there be these drive centers. Drive was a sort of a bundling term that we used for diversify, realize, integrate, venture, and educate. That's what the DRIVE stands for. And one of the things that they recommended as part of the diversify was to put together centers that brought together people who didn't normally work together to consider bigger projects than they could do on their own. And so really COFFIES is one of the outcomes of the last decadal survey. I was on that panel and I had a little input into naming what them drive centers, but not in terms of choosing which ones would be selected. But so it really does have very practical implications. And one of the reasons you're here today is because of that decadal survey that we did back in 2012 or 13. So they really do have impact. So that's all I wanted to give as an introduction. Sorry, there weren't some slides for it, but I thought it might be better just to talk through it a little bit. What I'd like to do now is just really go through the slides and materials that they use to present the decadal survey when they released it to everybody. And let's see if I can get the right one. There, are you seeing everything correctly?
Yes, we are.
Okay, great. So the process that they go through is really about a 2 or 3 year process. They start by appointing a committee, and we'll get to the committee in a minute. And then the committee accepts input from the community, and that takes about a year. And then as that happens, then different panels and groups look at those outputs, and that takes another year then to write a final report. And then it takes about 6 months or so for them to do the final version and put it together and get it approved and make sure that nobody's conflicted and all that kind of stuff. And then in the end, they have a big rollout. And for this one was a couple years ago now, Robin Millen and Stephen Fuselier, people I knew from previous ones, were the co-chairs. And so they would roll this out. And then there's another group, the group that sponsors it. Well, the group that organizes it is called the National Academies of Sciences, Engineering, and Medicine, NASM. And they have people who help with that. And so they've seen many, many decadal surveys over the years. They do, organize this one, the other ones for planetary science, astronomy, and for earth science. And so they provide sort of a background. They provide graphics. They organize the meetings and take care of it. But it's the science people who actually do it. And you can download these for free if you go to the National Academy's site. There's a QR thing there in the corner that you can look at if you want to. But otherwise, you can just find it by asking for the National Academy's. Sorry, my slide isn't advancing here. Let's see, hold on. How do I get it? Oh, there we go. Okay. Yeah, so you can download it yourself. So let me just kind of talk to it. Again, what they're trying to do is they're presenting a big picture. And so each one comes up with sort of its own statement of, where we are and why it's important. And so what they came up with is this: the heliosphere, home to our star and planet, remains the only known habitable system in the universe. Or as my professor used to say it, the sun is the only star known to grow vegetables. And what that really does is it gives you an idea why this is important for us as humans and us as Americans, and why the National Academy, why the national agencies should be supporting it. What they're really emphasizing is the next decade. And what they came up with was exploring and safeguarding our home in space. So there's really two aspects to this. There's the discovery aspect, which is more like you would think of as traditional astronomy, where you study the sun because it's an interesting star and it's the only star you can see, and you can learn about particle acceleration, you can learn about solar wind acceleration and coronal heating, all that from a sort of a purely scientific perspective. But the thing I think that's unique about heliophysics and about our part of astronomy is that there's practical implications for us here on Earth. And so space weather has a lot of effects that are important both for the country, but also for businesses and for people in terms of, are you going to be able to use your navigation system if you're flying on an airplane, or will there be a power outage or something like that? So there's really these two aspects to it. And for the first time, this survey, space weather was included as a separate and sort of co-equal thing with the science aspects of what we were doing. So it's a little bit different in terms of the emphasis in this particular survey. So what they lay out is that they have a balanced research strategy, and this is something that they're always trying to do, not just go off in one direction, but make sure that you do both big things and small things, identify things that are important and interesting, and also things that are practical and have real meaning. So they organize around themes, and we'll get to those in a few minutes. It, of course, uses what resources we already have. And then they also do an assessment of how is the community doing? Do we have enough? Do we have too many? Are there enough educators? How do we get new people into the field? How do we get the old people to retire? That kind of thing, where you're trying to build a whole community of what's going on. And then, of course, the third one is coordination, cooperation. How do you communicate with people? But the real thing that you can do when you do these decadal surveys is you sort of get out of your own narrow box of, what's my particular science question that I'm interested in, and how do you cooperate and collaborate and get things done that you can't. And like I said last time, one of the things that came out of the survey was the drive centers, and those are endorsed once again. They also talk about getting people who don't normally do science together, which is like us working with people who study the magnetosphere, for example, or someone who's studying the ionosphere, or even someone who's studying Earth science in general. What are the effects of the sun, and how does that ultimately affect life here on Earth? And then they sort of always make a wave at international collaboration. Sometimes that's more effective than others if there's already a mission going, but it turns out it's actually really hard to get those things to work. So there's a little bit of that, but not a whole lot. The way it's organized is they start at the beginning and they're given a very specific statement of task. So in other words, when NASA sponsors this, I don't know, they probably spend a couple $1 million on each one of these studies, these decadal surveys. They list things that they want from the study. And it's not just NASA, but NOAA also contributes, and so does the National Science Foundation. And so what they asked for was this, to provide an overview of the current state of solar physics and space physics and applications, including those things that are listed there. And then they want the highest priority science goals that should be addressed in the next decade. So they want not just a looking back, but also a looking forward, and a selection. Which ones are the most important things to do, and which ones are, if you have time, great, but you don't have to spend as much resource on it. And then not just a priority, but then the third element is a strategy. And that's what I was talking about before. When they actually look at the available budgets, they say we could afford to do a mission like this. We couldn't afford to do a mission like that. That one's too small to be worrying about. And so they actually come up with a plan for which missions should be done and what kinds of things you might do on those missions. And it has to be relatively realistic. They always tend to be a little bit ambitious, but not too much so. And then this time they were asked to assess the state of the profession. The steering committee is put together and it's appointed, and it's a balance of people. So there's people who are solar physicists, there's people who are magnetosphere people, there's ionosphere people, there's just a whole range of things. Some people involved with space weather, and so there's a list here of the 20 people who are on the panel, and they met and they started meeting. And what they do, though, is they don't do all the work themselves. What they do is they get other people to help. And what they do is they come up with panels. And so in addition to that steering committee, which makes the final decisions, they also have panels that are more specialized in terms of the different areas that they look at. So these are the sort of typical ones that we've had in the past. A panel on the physics of the sun and heliosphere. So that's where that's our most natural home as solar people. A panel on the physics of the magnetosphere. So that's the magnetosphere community. Ionospheres, thermospheres, and mesospheres, which is, sort of the lower part where the atmosphere and the space sort of come together. And then new this time was a panel on space weather and its applications. So we haven't had a panel on that individually before. And then a panel on the state of the profession. And so that group was the one that was looking at, how is the community doing? Are we spending the resources properly to make sure that everything is balanced right? So then in addition to those study panels, you have working groups, and the working groups sort of span the range of all of the different science areas, and then bring those together. So this time, and those groups are somewhat different from one decadal survey to the next. The top ones, the study panels, tend to be fairly consistent because they're the things that people are organizing their science questions around. But the things that have to do with, how do you do it and what are the questions that we want to look at can vary from one to the next. So this one was integrating ground and space observatories, because there are things that you can do from ground that you can't do from space and vice versa. And how should you balance those in terms of deciding what the science priorities should be and what should be interesting to do. So NSF would get more guidance about ground-based observatories, and NASA would get it about space observatories. Theory and modeling, how does that do that? So you don't just need observations, you also need to be able to understand and model the systems that you're looking at. This time data exploitation was big, partly because of machine learning, but partly because we now have really huge data sets, and it's much easier to share data than it used to be, but how do you make that effective? A group on access to space, which is kind of different. It talks about, the different size scales of missions that you have. How do you make it affordable to do CubeSats and do other things, and so on. And then communications, infrastructure, and innovations. And that's really where you're starting to think about what technology do you need now, but what technology you're going to need later, and are there things that we can do to make things work better. I'll pause. And are there any questions at this point? Because I can't see you.
Yeah, Todd, I had a question for you, just more of a clarification question.
Mm-hmm.
I'm recording too, so I'm also trying to adjust uh, what gets recorded here. But just to be clear, these various panels and working groups get together. Well, I don't know, maybe you're getting to this. So I don't want to jump ahead, but it kind of sounds like sometimes sort of fully conceived missions or almost fully conceived missions can be recommended versus science priorities, science goals that teams might want to address and then propose a mission around those goals. Is it a bit of both, or is it more one than the other? And am I making sense?
Yeah, no, that's a good question. It's kind of both, but there's actually a process that the National Academies goes through to evaluate proposals for missions. And so, this sort of ties into what is mentioned here. There were, 450 community input papers. That means there are 450 groups of people who wrote about what they thought was an interesting thing to do. And sometimes they would propose a mission or a project or a measurement that needed to be able to be done so that they could accomplish their project. Sometimes those were, well-established missions. So there was one called Firefly this last time, and there was another one called Solaris, which are two that I was interested in and involved a little bit with, that have either received some study money already, or someone has done a lot of development work. And so those come in as sort of complete ideas, but not necessarily completely done. Other times people will say, we really need a mission to go measure, let's say, high energy things. And their mission may be not as well defined. They'll still have some inputs. They'll still have some ideas about what inputs they need, but they won't necessarily have designed a particular mission to do it. One of the things that the committee does in consultation with the panels is take those ideas and evaluate how realistic they are. Now, the more work you've done to put together a mission already, the easier it is for them to do that evaluation. But it's rare for the committee to just take somebody's idea and say, yeah, this is exactly what we want to do. What they do is the committee will identify the science priorities first, in principle anyway, and then come up with something that can accomplish those scientific principles. Sometimes it looks an awful lot like one of those proposed missions. Sometimes it doesn't. But then once they have that, they identify a certain number of candidates and they send it off to a company, Aerospace Corporation, and they ask, okay, if we wanted to do this, how much would it cost? And then that company will take whatever inputs they can get, whether it's somebody who's already designed a mission or just some ideas of, mission or instruments that are like things that have been done before, and then put together a whole new mission. And it's those new missions typically that the academy will endorse, or that not the academy, but the panel will put forward as their mission. So, a long way of saying it's kind of both.
Got it. Got it. Okay, great. Thanks for clarifying. Really.
Okay. So this just tells about the community input. So it's, like I said, it's at least a year-long process. And on those panels and things that I talked about, they had 80 people, from the community who were involved with those things. And they actually had a couple workshops where people could come and present and talk to each other and, get some ideas of what other people were doing. And then there was a lot of communication and panels and stuff like that, both at the beginning, but also through it. Once you get to the point where the panels are meeting and not just collecting input, then the communication really stops, because they want it to be a deliberative process, where the people involved can actually have discussions without necessarily playing to an audience. And so the deliberations of the committee and the panels are all, I won't say secret, but they're certainly not public, and you're not supposed to talk about them. It's supposed to be internal until the release of the final document at the end. So it's kind of an interesting process, but anybody can write one of these community input papers, and it's a way, if you have an interesting idea of science, to really influence the process. So yeah, the usual thanks. And then what they come out with is a report, and it can be 100 to 400 pages long if you include all of the panel reports. And they have sort of a history of what's going on in solar and space physics. And then the second chapter is what's going to be new. The third one talks about that and how it relates to space weather and why it's interesting. The fourth chapter has to do with a community survey. The fifth chapter is where they roll out, okay, given all those interesting science questions and what we need to do for our community, here are a set of missions and projects that we think you need to implement, and here's how much money you should spend on research grants versus community models versus something else. And then chapter 6 just kind of rolls it all and talks about the budget and stuff like that. And then there's appendices where they give a lot more detail. But the only thing that comes up with recommendations is this study report that the committee itself puts out, not the panels. So the committee in the end is the one that's in charge of all of that. So then this is what they do in terms of the beginning. And so they go back and they review what's been accomplished in the last year. They can refer to what happened in the previous decadal survey. They can talk about some interesting observations that have been made. They talk about the questions that were addressed and which ones weren't. And they can talk about science that other people have done and how what we're doing affects those. And so they basically just summarize those things in all of the different areas. So each of those panels, the discipline panels, will come up with a report saying, well, what interest happened in solar physics? What was interesting in the magnetosphere? What was interesting, in all the different areas of heliophysics? And there'll be a report on what that is. And then they'll talk about, the infrastructure that there was to support it too, which missions were launched, which ones weren't. They can talk about, what got accomplished and what didn't get accomplished from the last decadal survey. So in fact, for the last decadal survey, one of the missions, dynamic, didn't get completed. In fact, they've talked now about canceling it. So there was, some discussion of that as well. But this is the part that's I think interesting for a non-specialist to read. One of the things that they mentioned was the space weather, and how much the importance of space weather has changed, which is one of the reasons it's one of the new science areas. And they talk about the number of customers, so that the blue part of this graph tells how many different people are receiving reports from NASA every day or every week or every month, related to space weather. And so you can see that from back in 2010, where it was like 20 or like 10,000 people, now there's about 70,000 people who are looking at, or 80,000 people who are receiving alerts and interested in space weather. And that's everybody from airline companies to power companies to SpaceX to, people who are interested in, guiding their tractors around their fields using GPS and stuff like that. So there's a huge community out there. And it's also interesting to see how the number of satellites in orbit has gone up. And they're also interested because the environment around the Earth has big effects on how they operate their spacecraft. Let's see, I don't know how we're doing for time here. So the vision and missions, this is the science themes. So vision is just a statement of, what do you like to do? And discover the secrets of the local cosmos and expand and safeguard humanity's home in space. So home in space. So again, that two-part thing. And then their mission is also two parts: explore our habitable cosmos, in other words, the part of the world or part of the cosmos around us, and then to look at, the only habitable system in the universe and explain the physics and interconnections of the heliosphere to understand the conditions for life elsewhere. So in this case, quite a bit about the practical, but also serving humanity in terms of analyzing the space environment, so that you can plan what your satellites are going to have to encounter in the next year and 10 years and 20 years, and then develop products to do space weather warnings and forecasts. So that's really helping move it from a scientific viewpoint into something that's practical. And then they have science themes that they identify, the sun, earth, space, and that's about the interconnections. How does the sun affect the heliosphere? How does the heliosphere affect the earth? How does the heliosphere interact with the interstellar medium, and how all those things are connected? Another one is the laboratory in space. So this is really, how do you learn about physical processes on different size scales and in different places around where we can actually observe them in ways that we can't observe them either elsewhere in the cosmos or here on Earth, because the scales are different. And so, shocks accelerate particles at the magnetosphere, but they also have effects near the sun when you're accelerating a coronal mass ejection. And reconnection is driving explosions on various size scales, from particle acceleration to solar flares to CMEs to the aurora to everything else. And so you've got these huge range of scales that are involved. And then new environments is basically looking at the phenomenology and the things that are going on in the world around us. And how does our planet, for example, look like or not look like Uranus or another planet? So it's really looking for those connections and linkages to other parts of science. And then they go down and they come up with, for each of these things, sun, earth, space, for example, they have a number of research focus areas, and they'll identify, several. In this case, there were 3 of them. And for each one, they will develop a set of science questions and a set of things that are interesting to look at for the next 10 years. And so this one is energy and momentum flow. So the upper atmosphere is driven by solar radiation and other things that are impinging on the magnetosphere. And it's also influenced by weather up from below coming up into that partially ionized medium. And so how do those two things interact? And how does the energy flow? Where does the momentum go? And so then they illuminate that by talking about the observations that are needed, and what's driving what do you need to know to measure this, and basically laying out for these top priority research focus areas what you need to make progress in the next 10 years. There are a whole bunch of those. They just listed one. You can go to the book to read about more. Then there's space weather. And one of the things that you learn about when you do space weather, of course, is, well, the sun interacts with everything else, but not much affects the sun. But you need to understand the sun. You also need to understand the solar wind. You also need to understand the Earth. You need to understand the magnetosphere, all those things. So it's really a system that is made up of other systems, each of which needs its own study. And then there's space weather responses to the physical system. We've all seen the nice auroras in the last year or so. But, of course, that's just the tip of the iceberg. It's the things that affect us are more about radiation environments, effects on spacecraft, the electric fields, the power grids, and that sort of stuff. So all of these things are really, the topics or the themes for the Serve Humanity part. One of the things that they did in this case was they wanted to identify, tangible goals. And so what they want, for example, is what do you need to do a 12-hour forecast for solar flares and 6 hours for energetic particles. So they identified, particular things that you think are needed and achievable in the next 10 years as part of their development in the project. And then they talk about how the themes for science, which was that first one, are connected to what's going on in space weather. So you can't, it's not just a system of systems. It's also, these things are both the same and different, right? You just look at it a little bit different. You might not care about the details of reconnection to make your space weather forecast, but if you don't understand the laboratory in space and how reconnection works, you're not going to see what's going on. And so this is really a recognition that it's all interlinked, one thing with another. So then they came up with a strategy for the next year, for the next decade with space weather, and they identified 6 different things that needed to happen. Space weather, like I said, is relatively new. There's been a lot of interest in it at the congressional level. They care about it for Department of Defense. They care about it for Commerce. So they identified these 6 different areas where there could be progress in the next 10 years. And then each one of those gets an explanation. But this is the first place that you also see recommendations. So they make recommendations for NASA and for NOAA and for the National Science Foundation, and then for the group of them all working together. And then the state of the profession, they talk about 4 things. We can't talk about the third one anymore, according to our current administration, but the other ones are still quite valid and funded. Demographics of the workplace, in other words, where are people working? Are there career pathways for everybody? What do we need for the future to encourage people to get into the field like you guys? Solar and space physics education. Why are there so few places in the country that are teaching solar and space physics, and what can we do to affect changes in that? How do we attract the best people, and how do we make an inclusive and accessible environment for everybody? And then reaching out to the public, because of course, in the end, it's the public that pays for all of it. And so we'd like to make sure that those people are included as well. And then they come up with recommendations in this area too. Some of them are sort of technical, like have a survey so that we know more. Start a program so you can have more faculty in geospace sciences, increase public outreach in citizen science programs, and they come up with ideas for all of these things. Okay, I guess we have about 10 more minutes. Is that right, Dan?
Yeah, we usually end at 4, so we want to save some time for Q&A. But
Okay, so
it's a small group today, so you could go a little longer.
Okay, so I'll just kind of go through this, but maybe a little bit more quickly. So they identify sort of the Heliosystems Laboratory, which is a way of saying all the things that we already have. So we already have the Solar Dynamics Observatory, which is the one that I've been involved in. We already have instruments around the Earth that are measuring all sorts of things. There's the WIND spacecraft. There's just a whole host of them, all right, in different places. Carruthers is coming up. There are others. And so they go through what's available. So DKIST, everything else, and how do you use those things in a way to provide the observations that you need. And then they talk about enhancements to the research and technology programs. So in other words, do we need another drive centers? Do we need something special for technology development? And then what do we do looking forward? How do we get high rate data from far away places? And based on the missions that they'll recommend, which I'll get to in a minute, what technology needs to be developed to make those practical. So the Integrated Heliosystems Laboratory is just a map that shows all of the different spacecraft that are in place. You've probably seen maps like these before, and it also lists some of the things that are on the ground. And so their recommendation is they should managing these assets and maintain as many of them as they can. And so this is something that you take to Congress and you say, hey, I want to keep running SDO. It's really important. See, look, it's in the Decadal Survey. And everybody else who has a mission will do the same thing. So if there's enough money, that's exactly what we'll do. And then you use the data from the systems laboratory to drive, which is, as I mentioned, the diversify, realize, integrate, venture, and educate. How do you actually do the science, right? You have people who are actually going to use it and have grants and do technology development and develop tools for other people to use to accomplish your science. And so they set aside money for those different things too. These are the things that they're recommending. So now we're getting into recommendations for ground base. I'll just mention NGGONG, which is a global network of sites around the world to do helioseismology and measure the magnetic field. Phaser, which is a frequency agile solar telescope, radio telescope, can measure magnetic fields in the atmosphere of the sun that you can't do from any other way. And then one for instruments on the ground to measure conditions on the Earth. And so these are the recommendations for the ground-based part. They recommend a suborbital program. So if you're going to work on a rocket or you're going to work on a CubeSat, this is the program, and they recommend a certain amount of funding for that. How do you enhance the space weather program? NASA should grow the spaceflight elements of the space weather program. That seems kind of obvious, I guess, in a certain way, but there aren't actually currently any missions that are really just space weather oriented. And so they're suggesting that there should be. And then how do you incorporate space weather into missions that already exist? The Explorer program, which is sort of a medium-sized mission, they don't actually specify which explorers should be chosen. They leave that to NASA to figure out with the community based on the science priorities, but they don't actually suggest or design these sort of mid-sized missions. And they could be things like Punch or like there's the one that launched recently, and there's a host of those as well that are more narrowly targeted. And then the bigger programs, Dynamic was not funded yet last year, and GDC either, I think. And so they really want to emphasize that those are still top priorities for those communities, even though they haven't been realized yet. So it's really a way of endorsing the unfinished part of the previous one. And then they have two new missions that they recommend. One for the solar terrestrial probes part, and that's the STP project. And another one for a solar one called Solar Polar Orbiter, which will take the first images of the high latitude sun, and then also be able to look down at the ecliptic plane from above, so you can see things evolving in a much different way. And that's one of the ones that I was really in favor of, because I think there's some really interesting science questions there. So my white paper, at least I hope, was part of the process to make that happen. And then they talk about research and technology and how you should do that, and then enhancing the programs. So, how do you make sure that you have an archive of data? If you're going to collect all this data, you ought to spend enough money for people to actually analyze it. And then they talk about how do you transition some of the science that you get from NOAA to the DoD or to the Space Weather Prediction Center, and how do you make that? It's been a problem in terms of actually getting something that is a really cool science idea and sort of works most of the time to be something that you can actually implement by people who are coming and going and aren't necessarily science trained. And so that transition from basic research at the top down to operations at the bottom is one also that they wanted to support. They recommended a large community level science modeling program. So just like there's one big atmospheric model for weather on the Earth, they're suggesting that there should be one for the community sciences as well. And then here's where the drive centers and the space weather centers come in. And then they have some technology recommendations. I'm not going to go through these, but there are other missions, both for heliophysics and others, where there's sort of some overlaps in terms of the science interests and what should be worked on together. Okay, so that's really it. I don't have a whole lot more to say. Their takeaways is, they want balanced things, and they've identified some really interesting science topics, and these are the ones that we should go do it. And of course, to do that, you have to have a thriving community to make it work. And then a nice statement at the end. So I think that's where I'll stop. So I will stop sharing my screen and let me see, is there one more? Oh yeah, thank you. Okay. Okay, so if anybody's still there.
Yeah, I think we're all here. I'm gonna get out of full screen mode because I just don't like the way it's graphically presented. But if we have such a small group today, if you have a question, just feel free to use the raise your hand function, and we'll call on you. But while you think of potential questions, I have one. You talked a lot about space weather. Obviously, space weather, in essence, occurs throughout the solar system. But if I'm, say, at a scientific conference and people are talking about space weather, can I just assume from the get go that they're talking about basically sun Earth connections and such?
Yeah, pretty much. We don't have many astronauts on Mars. So yeah, that's the basic one is, it's how does it affect humanity, really? The only exception to that would be, for when people are thinking about habitability of other planets. People are interested in how a star affects its environment, so the radiation environment and everything else that goes along with that for, how do planets develop? So it's a longer term question, obviously, right? It's more space climate than space weather.
Okay.
But yeah, when it comes to space weather, it's usually related to things where you are affected by it. So yeah, it's a pretty safe assumption.
It might get extended out to Mars in the near future.
Well, as people go to if people go to the moon soon, right? There'll be moon as well as the Earth, right? And we do have satellites in other places around the heliosphere, and those all care about it too. So, James Webb is out at L2, which is a million miles downstream in the solar wind from us, and they care about things like that, right? Solar panels can be affected by radiation storms. And so if we know there's going to be a radiation storm, sometimes you do things to your power, the way you operate your spacecraft, that have effects. So yeah, it doesn't have to be just here.
Okay. Excellent. Excellent. All right. Let's see. Any other questions from the audience here and or even the HelioHub team?
And so I still remember when I went to NASA headquarters back in, well, 20 years ago or something. One of the first things I got was a call from Lou Lanzarotti, who was known for being kind of a cantankerous guy who had led the previous decadal survey. And he called me up and said, "Why are you not doing my survey right?" And so he gave me a little bit of a tongue lashing. And then I told him, "Well, we are actually doing it. We just changed some of the names." And, but basically, he was being an advocate. And by having the decadal survey to back him up, he could call up people at NASA and say, "Hey, why are you not doing what we told you to do and that you promised to do and that Congress funded you to do?" And so then we had to be able to explain, well, either we were, or, it's possible that they can't too, because it turns out that the priorities have changed or there isn't enough money. But you really are held to account for that. That sort of brought it home to me.
Interesting. Wow. Has the decadal surveys ever come out with their final report that includes, say, the recommendation to end a mission?
No, they're pretty careful about
Okay.
not saying things like "Stop Sophia," right? Which is, one thing that was sort of
Right.
discussed, right? And so they don't talk about existing missions much, except to say that they're important, and they might endorse some more than others, but they're not going to say you really shouldn't be doing this. They leave that's really an implementation question, and they try as much as possible to stay big picture. Like, you should be doing these things to get to this goal, and
Okay.
here's a way to do it. But they don't necessarily tell the agencies exactly how you're supposed to do it.
But they think of the active missions as part of the laboratory and the resources and
Yeah,
such, and
yeah, that's right.
mention them when they seem to be useful and such, or
Yeah, or they might say, here's a new mission that we want to do. You've got a mission that already does some part of it or needs to be there in order for that to work. as well as it could.
Right.
So they can do that a little bit more, and they can stress the continuity of measurements as being important. But yeah, they're not gonna tell them to turn any particular thing off.
Got it. Got it.
Not
Okay.
that NASA ever does, hardly anyway. But
Got
usually, if it's working, they keep running it.
it. Okay. Well, somebody here has to have some questions, I'm sure.
Are there
What's
any like
behind you?
sub
There
oh,
you go.
so- are there any like sub-decadal surveys that occur like within each of these three fields? Okay.
Yeah, they do after a 5-year period, they do what's called a midterm assessment. And the assessment is not allowed to set new priorities, but it is allowed to say, we understand why you're not doing this, and that's okay. Or you're not doing this and you really should be. And so it's a way to give a report card from the community back to the agencies, but more importantly to Congress, about, are you actually making progress on the last decadal survey or not? And if so, how are you going to fix it, or why aren't you? So yeah, there's that is a much smaller thing. They still have panels. They still have a group that does it, and they still spend a year and a half making the report. But yeah, they really do that, and it's actually quite useful. The National Academies also runs an ongoing Committee on Solar and Space Physics, CSSP, that meets a couple times a year, and they sort of do that, but less formally. But they're constantly also hearing reports from the administrators at NASA or the National Science Foundation and reminding them of the priorities in the decadal survey and asking them, how are things going? So there are a couple feedback mechanisms that are on the scientific side. Um, and then, when the reports are finished, not quite answering your question, but when the reports are finished, the leaders tend to go to Congress and have a time where they go and meet with the relevant committees or the relevant committee staff, or, Congress people who are influential or interested, and advocate for the program. But that usually only happens in the first year or two, and then they leave it to these other mechanisms for the feedback. And I have to say that the community usually gets behind it. So even if your mission isn't selected, you're sort of honor bound not to snipe and say bad things about the missions that were selected and good things about your mission that wasn't. You can come back in 10 years, or you can, more often what happens is people who have something that they think is important will find a much less expensive way to do part of it. And so then they'll submit an Explorer proposal or a CubeSat proposal or a rocket proposal to do a piece of the science that they wanted to do instead. But the Academy's reports don't endorse those missions on that scale. So what you really have to do is make sure that your science is included, even if it isn't necessarily the top priority thing for a mission. And then you can argue, well, it was mentioned in the survey, so it's important. It just wasn't quite important enough, so I can do this thing instead. But I think it's kind of cool the way they actually take seriously those 480 reports that they get and really work through it. And I think they really struggle isn't the right word. They're conscientious, in terms of making sure that they actually read them carefully and understand what's going on. And most of the things in those reports aren't surprises. Um, because you kind of, if you've been to a conference, you've heard people talk about the contents of those things before. But often it's written in a way that helps you make the case, and it helps you refine your science questions too.
All right. Any other questions? Can we ask you about your background there?
Yeah, this is a decist picture. So it's a high resolution image of the sun. And so these are granules right about here. And these are overlying magnetic features that have sparkly things in them where the magnetic reconnection is going on, and you can see some dark filaments over here. This isn't a sunspot. It's basically what you'd think of as quiet sun. And this is probably a supergranule boundary up here where you've got magnetic field in those areas. So the little ones are just little magnetic concentrations, and the other ones are, sort of in the atmosphere, suspended above the surface. So this is Texas, the size right here.
Huh.
So this is one of the images from DKIST, which is a 4-meter telescope in
Okay.
Hawaii on Maui.
Fantastic.
Yeah, they're really fun.
All right. Well, the clock behind me is actually a little slow, so I show it's actually 4:04. We usually end at 4, but Todd, we can't thank you enough. You're not only generous and incredibly smart, but you always do a fantastic job of delivering messages in digestible ways, meaning,
Well, thank
even
you.
lay people like myself can follow along. So yeah, can't thank you enough. All right, well, we'll give you back the rest of your day, and I'll end the recording. So thanks everybody, uh,
Okay.
and we'll be here again next week. Claudia, do you want to give a heads up about next week, or is it Phoebe who knows more? I forget who knows more.
Yeah, me probably. We'll be doing the like Helio mission spotlight, and it'll be the Parker Solar Probe. But we also have a poll in the Discord chat.
Right, right. Yeah,
So if
say
you
more
guys want
about
to
the
pick
poll.
the following one,
Yeah, we want to go in depth on two Helio missions this year, and Parker Solar Probe seemed like a no-brainer, but we want student input on the second one. But Todd, while we have you, if you thought that a particular Helio mission, we already highlighted the drive center, so those are covered. But
Well,
if you,
Punch is new, and it's got
yeah,
great imagery.
okay,
So I would take a look at Punch and some of the other things that have done imaging of huge parts of the inner heliosphere. There's a couple other missions. Stereo also had a heliospheric imager. Looking at how things move from the sun to the Earth. There's up until now, there's been these gaps in our understanding and our observations of what's happening. So I would go with Punch because it's new and it's cool.
great, great. All right, well that's on the list, so we'll take that recommendation. Okay,
All
thank
right.
you so much. Take care,
All
everyone.
right. All right.
Bye.
Bye.
thank you.